afternoon, everybody. This is 4501, Mechanical Design 2, and Project 1. I'm Hosni.
My name is Juan.
And my name is Juan Cardona.
And today we're going to be talking to you about terraforming Mars. This is the project that was assigned to us, and let's start. So basically, as a civilization for the people that are involved in the space traveling business, our main objective is one of our biggest goals is space settlement, and they basically want to find an environment that is suitable for sustainable life, a counterpart, if you can say, to counterpart Earth somewhere else. And why do we want to do that? Because Earth is dying. We are killing Earth. So that's when terraforming comes in. Next slide. From a lot of research, from looking into all the planets, Venus, Jupiter, Mars has came up as primarily planet that can sustain life. And these are the things that Mars are missing, basically, to create a sustainable life. We need a breathable atmosphere, we need a sustainable ecosystem, and we also need an ozone layer which can be conducted. And we're going to take you through this briefly in a moment.
So current discoveries on Mars include NASA and other space agencies sending satellites and rovers to the planet in order to conduct research and really investigate the surface of Mars and what kind of habitat and ecosystem it has on the surface. Of the most recent rovers that have been to Mars include Spirit, Opportunity, and most famous of all is Curiosity. Curiosity is landed on Mars about 4 years ago and has been conducting phenomenal research ever since. It's collected amazing images and visuals of the surface of Mars, and has also gone into what's located as far as within the soil and other signs of life and water on Mars. So at one point, Curiosity dug into the ground and took in soil samples that found basic building blocks of life. This included CO2, methane, and nitrogen. And these are all elements that are fundamental to all life forms that we have here on Earth. So finding these elements was a substantial success because of the fact that it suggests that Mars has the capability of housing life forms on the planet with very, very little help with terraforming. Additionally, shortly after landing on Mars, Curiosity came across a dried up riverbed. And it was determined that this riverbed was about the depth of around knee height, and it showed that Mars has the capacity used to actually house large bodies of water. Because it showed evidence that it used to have large bodies of water, it suggests that Mars can later on also do the same thing again with the correct capabilities from terraforming.
So actually, right now there's existing technology for us to travel to Mars, but the problem is that we wouldn't be able to come back. And as a matter of fact, there's a private company called that's starting a mission called Mars One. This isn't a mission funded by NASA. This private company plans to send a group of 24 people to the planet Mars, but they wouldn't be able to come back. And the good thing about this is that these people will be able to do research, and that way we will be able to learn more about Mars in a more efficient way. Because the problem with rovers is that in order for them to make their discoveries, it takes them months. And if people go, things that a rover could have done in 2-3 months, the person can do it in 2 hours. So it'll be a lot more efficient. And this mission plans to be done in 2026, around the year 2026. Yeah. So as Omar was explaining, the planet that's more similar to Earth is planet Mars, but the problem is that there's not a breathable atmosphere and there's no greenhouse effect, so it can't stay warm. And there are some different theories on how we can terraform Mars. This can be done. One of these theories was introduced by Christopher McKay. His proposal is to release CFCs into the atmosphere, and what that would do is trap the sun's heat and wouldn't allow it to leave. So that would warm up planet Mars, raising its temperatures up to even 70 degrees Celsius. Melting the frozen water in the poles and releasing carbon dioxide into the atmosphere. And once carbon dioxide is in the atmosphere, then the planet's going to have a greenhouse effect, so it will stay warm.
And the thing about this one is what Christopher McKay said is in order for us to collect those CFCs and basically free them to the Mars atmosphere, it's going to need an enormous amount of resources, because basically the factories that are going to be collecting those CFCs from Earth, from the soil and water, are going to be like using a huge amount of power. What he said is one factory would basically need a nuclear power plant to power it in order for it to collect those CFCs. And at the very end, after all this, after water has been created and the atmospheric pressure has rose enough to sustain human life, we will still need oxygen masks to survive over there, because there's no solution yet to convert CO2 into oxygen in order for us to breathe normally.
So another proposal was done by another NASA engineer. His name is Dr. Joel Ludden, and his proposal to warm up Mars was to create a reflector in space that would warm up the surface of Mars, reflecting the sun's rays. So that would again cause the melting of the frozen water in the poles, and again releasing carbon dioxide into the atmosphere and creating a greenhouse effect.
The main problem with creating such a solar reflector is that it's beyond the capabilities of current manufacturers. The mirror would have to be 200 kilometers in diameter, and if it was produced out of, say, aluminum, it would weigh over 200,000 metric tons. In order to transport something like this, it would have to be produced in space, because current rockets don't have the capacity to load such a heavy object. So something like this is totally out of the scope of manufacturers today.
So once we have a warm atmosphere, the next step will be to seed the surface of Mars with photosynthetic plants. That way the plants will convert the carbon dioxide into oxygen, and we will create a breathable environment.
Trying to create an ecosystem that creates breathable air on the planet of Mars would take a very long time, possibly decades or even centuries, to actually create such an atmosphere. The microorganisms and the plants would be producing such small amounts of oxygen that it would require external equipment to actually compress and produce the gas that we need in order to breathe. And additionally, it would take even longer to set up the ecosystem that would be able to produce these gases.
So once we have oxygen from the photosynthetic plants, the oxygen can be broken down by solar radiation, creating ozone. Then this will create an ozone layer that will protect the surface of planet Mars from the ultra solar radiation of the sun.
So, and then to sum everything up, as you can all see from the presentation, it's basically a really long shot for us to terraform Mars from the aspect of the economy, or the aspect of the machinery that we don't have at the moment, or for the progress that needs to happen within our civilization to achieve this. One day, maybe our children's children will probably go to Mars one day. So, in my opinion, what is the biggest question? Should we try to spend that money on saving Earth and live on Earth, or should we keep going, digging further into space and trying to find another sustainable life somewhere else? And this, what might hopefully Mars look like one day, it should go from this to being terraformed and looking like this. that's our presentation. Thank you, everybody, and that's it.
Just over 10 minutes.
That's perfect.
Just a couple seconds.